install Rhinoceros and you load Rhinoceros, RhinoCam plugin is automatically loaded when RhinoCam starts up. That's the beauty of it. So you just have one application to run and it automatically runs the CAM plugin in Rhino. Now once you have your part designed, you can just load it, either open it or import it into Rhino. So I'm currently in the process of importing this file into Rhinoceros, the one that you emailed us here. So it looks like we got the part loaded. So I'm going to click on shaded viewport, and that basically displays the part in a shaded view. So it looks like from the way the part is designed, it is probably not in the desired intended orientation for machining. So you would need to orient the part so that the base of the part is laid on the XY plane. Is that right, sir? So we would have to rotate the part. So you can take advantage of your tools that you have in Rhino to rotate it. You can use the gumball and you can rotate it. Okay? So there's several different ways how we can rotate it. If you also need to rotate it around the center here, you can basically select this and then go ahead and rotate it the way you want it to be oriented. So as you take a look at the part looking down from the top view, you want to make sure that the part is in the intended orientation or the correct orientation for machining. Is this how you'd be typically setting it up for machining, sir?
Yes.
Okay, perfect. All right. Now, so as you notice here, the RhinoCam's interface shows up in Rhino. You have the mill browser. The mill module allows you to basically program 2 to 5 axis milling and routing applications. We have both indexed and we also have simultaneous 5-axis milling capabilities depending on what your needs are. Now, RhinoCam also offers other modules like turning for 2-axis CNC lathe programming, nesting for 2D parts, and also an art module. You can go from art to part. By default, the mill is selected, and that's the interface you're seeing here. Over on the left half, you have the machining browser, which appears over on the top half, and then the machining objects that appears on the lower half of the screen. And there's 2 tabs in the machining browser. You have program and simulate, and you work your way left to right as you work through each of these groups in here. So the first step is we want to define the machine tool or the machining process. We have 2, 3, 4, and 5-axis types of machining methods. For 2 and 3-axis, you would pick 3-axis, and you have 4 and 5-axis. So in this particular step, I'm going to pick 5-axis right in here, and I can establish the configuration of the machine. So the one that you're getting from Motion Master, that would be a head-head machine where the 2 rotational axis is on the spindle itself. So that would be something similar to what you would see here in this example that shows like a head-head machine. There's 2 rotational axes.
Yep.
Okay. So once you specify the configuration as head-head, you would then set the primary axis, which typically is set to be rotating on the Z, and then you have your secondary axis, which is typically on the Y, or it could be the X. And then you can also enter in the gauge length if you need to do the compensation of the gauge and the CAM software. And some controllers, they automatically do it on the on the machine itself. They use what is called a G48.1 to do a tooltip compensation on or off. So if you're doing it at the controller, then you can leave the gauge length to be a 0. So that'll be the distance from the pivot point all the way down to the tooltip. So if you need to compute for the compensate for the gauge length in our software, you enter the gauge length in here, which is the distance from the from the pivot point to the spindle face and the collar face, and then we automatically add the tool length to it that's defined in your tool definition. And all of these settings that you put in can be saved into a knowledge base, so when you're working with other parts, you don't have to go through the process of defining it in each step.
Right.
Okay? You can also establish your rotary axis limits for primary and the secondary. So primary could have no limit, the secondary could have like a -2 + 110 or whatever the angle limits of the secondary or the B axis is, can be specified right in here. In the next step, you would want to select your post processor in here, and we do have a post processor for a wide range of machine tools, right from 3-axis all the way to 5-axis. Now I have a bunch of posts in here, as you can see, for the 5-axis machine tools. I have one for the Motion Master 5-axis. We can take the post, we can edit, we can customize it, we can add any additional information as needed to the post processor in here to fully customize it. So we also have a wide range of figure posts in here as well, which can be used with the Motion Master, like if it's an 8055 or 80 65 or 80-40, depending on whatever the controller is.
80-55.
Okay, so I have a pose right here. We can specify Figure uses NC or even .pim can be used for the file extension, so we can use any of the file extensions in here for the Figure as well. All right, so we got the machine set up, the post is defined. The next step is you wanted to make sure the part is in the correct orientation for machining. So we already established that by looking at it, looking down from the top, you make sure it's in the correct orientation. And now you want to establish your XYZ0 for machining. So when you place this stock material on your CNC router, where would you want to set your XYZ0, right? So in order to do that, first step is to define your stock. Your workpiece could be a rectangular block, or you could be doing a cylindrical blank. If you want to do a cylindrical blank, you can select a cylindrical blank right in here, and it automatically computes the radius and the length. It tells you that the minimum radius you need is about 47 inches, and then the length, or the height, or the thickness of the part is about 14 inches.
Here's a question. This piece is too big for the stock that we can normally buy, so we have to machine it in 2 pieces.
Okay.
So what would be involved in that? Like we have to cut it into like 4x8 sheets. Would have to be done in 2 parts. And that.
Okay, 2 parts in terms of X and Y, or are you slicing it up in a Z you're talking about?
No, slicing it X, Y, across the, like probably right across the horseshoe or across the middle. Doesn't really matter which way we do it.
We could do it on the horseshoe. So one of the ways I could do it is I could, the easiest way for me to do that would be select this part, and I can say I want to move the center point to the origin first. I'll do a transformation command in Rhino. I'll put the center at 0. Okay? So the center of that is at 0, and now I can define a circle and split it in 2 halves. I'm going to put a circle starting at 0 and then give it a radius. Would that be like a 48-inch radius or slightly 47.5 radius, right? And I have the stock defined right here as you see it, right? So the stock still needs to be larger than this here. So I'm going to make a slightly larger piece of stock. If I go back and check the stock size in here, so that has to be 95, 91, 14, right? So about 96 inches on the x-axis, right? So what I'm going to do here is put a circle, and center would be 0, and then radius would be 48. Okay, so I drew a circle in here, and I'm going to split the circle in 2 halves. So I'm going to basically split it. I will use the split command in here. I'm going to use the split command in Rhino, and then I'm going to use a point, and then I'm going to split it at the 2 quad points of the circle. Okay?
Yep.
I'll pick this and do a closed curve. So it basically connects it by adding a straight line. I can do the same thing here and do a closed curve. So we have 2 closed curves in here, right? So we are taking advantage of all the CAD tools that you have in Rhino, and now I can select this part. So you're basically going to glue 2 pieces together. Is that right? After you machine one at a time, is that correct?
Yes, exactly.
Okay, so now I could take this piece that I have, and I can use what is called stock by extrusion in RhinoCam, and you can specify the height for it. So it's going to be 14 inches, and the stock is defined for 1/2. Okay, and currently the 000 is set. As you take a look at the stock only, you see that the 000 is set at the bottom.
Yep.
And right at the center. So I could program one of these pieces in here. So that's basically exactly where you're going to be establishing your 0 on the machine as well. So once you've established the 0, you're now ready to program the part. Now it probably might be better if you split it across the other side in here so that you can cut all of these uniformly, right? So that might be a better way to do it. So rather than splitting it in half.
The lettering itself will not be machined in the part.
Okay.
That's
So all of these in here that you have, it might be better, I'm thinking, if we rotate it by 90 degrees and then, split it in half this way, right?
Yep, sure.
So we can go back and redefine the stock in here. I can pick the lower half or I can pick this half, whichever one you want to start with first. Let's do the lower half first. And I'm going to do redo the stock from extrusion. And now the stock is defined. So you have the lower half being defined right there. You see how easy it was to just rotate the CAD model and then program it, right? So now we have, the stock defined, the origin defined. Now, if you're not going to be working on the letters, which means you don't want the letters to be machined, is that correct?
Yes.
Okay. There's a couple of things we could do is we can get rid of the letters, because if you're going to be doing a 3-axis toolpath, it's going to look at whatever is visible in here to cut it on the top. So if you want to delete the letterings from the model, you can modify it in the Rhino CAD in here, and you can go ahead and explode this model in here. In Rhino, you can do an explode, and now you can see those letters are there. You can go ahead and delete them out. You can take it out from the model right in here. So I can go ahead and use the CAD tools in here to go ahead and delete those. Right? So we delete those letters, and now I can also do an untrim, and I can just basically select these. Right? So that's a powerful tool that you have in Rhino. So you're using a combination of Rhino's tools to basically make whatever changes you need for your design right in here. Right? So you got rid of the holes. But you could have still kept the text in there if you wanted to just engrave them at a later point of time, right? Now, do you still want to do the same thing for these as well, the text?
No lettering in there whatsoever.
Okay, so we'll go ahead and do the same step. I'm going to go ahead and select these in here, delete them, and do the untrim operation in here. All right, and then we do the same over here as well. So select these text out, delete them, do the untrim command, right click, recalls the previous command, and all I'm doing is selecting those.
Thank you so much, Michael, and I'll make sure to follow up with you now.
Okay, so we got all of this here. Now I'm going to hit save to save the file. I'll just put it in the same folder where we started out with. Would there be any questions so far, sir?
Good.
Okay, now you see that there's a draft in here, right, on the top of the surface in here, and we only wanted to do 1/2 of it. So what we could do first is start with the roughing process. We could do for the top areas, we could just do a roughing. So we could use 3-axis, and we can start with the roughing process in here. And for the containing or constraining the toolpath, I can just pick this boundary curve that you created already. I can use that for as my boundary curve to contain it. And then specify a tool. Would you want to use like a 1/2 inch or a 3/4 end mill, or what size cutter would you like to use for the roughing process?
Big, yep.
Something that's big, right? 3/4 end mill. You can define the properties for the tool, like the tool length, the flute length. So I can put in, for example, 4 inches. I'm just going to leave it at 4 inches for now. And I'm going to accept that. And we can also establish feet and speeds based on the material that you're cutting. We have a library of materials, and this library can also be, enhanced to add additional material types. For example, if I'm going to be cutting something similar to wood, I can specify the material to be carbide, and based on the tool diameter and number of flutes, you can see that the feet and speeds are estimated. And you can use this as a reference. So you want to modify your spindle RPM, the cut feed rate is automatically recomputed. You can update this, save this out to your tool, and then the tool can be saved to a library. So we have a tool defined, the feeds and speeds are set, you have your clearance in here, and then the cutting parameters, we can establish all the cut conditions, the roughing parameters like the tolerances, the stock allowance, the step overs in here. We can specify those cut patterns for core and cavity regions. In the cut levels, you can specify how deep you want to cut. So we only want to cut up to a certain point in here. You can use these tools. You can also pick a point, like a near point, and say you only want to go right up there to that location. You want to go slightly below that, so you don't want to go too far deep. So you have very nice graphical controls as you see right here.
One quick question. CAM file, does it talk to the computer, talk to the CNC to know where to pick that tool up from?
We output a tool number like a T followed by the number and then M6. So basically that tells the controller to go grab the tool number. So when you have an automatic tool changer, it'll just go grab it from there. So all you need to do is make sure the tool numbers are set correctly in your program to match what location of where the tool is on the machine tool.
Okay.
So we are computing this toolpath right now here. As you can see, while the toolpath is being computed, you can create additional operations. So for example, if I want to go back and machine this pocket in here, so now the roughing is completed, and you can see the toolpath is doing it in layers or levels. It's only going down 50% of the tool diameter for each level, but if you want to take a deeper cut, you can always modify it. So it's only going like about 3/8 of an inch. And now here we can also run a verification. You just select the play button. You can see how fast or how slow you want to run the simulation. And there's your cut material verification in here. You can also slow down the simulation as you need to. And anytime you can do a pause and then pick simulate to end, it'll actually run through the entire simulation in here, and it gives you the result of the simulation in just a moment. Would you have any questions so far?
Looks good.
Okay, so you can see the power of being able to work inside of Rhino and also be able to use the Rhino's CAD tools like for selection, for creating boundaries, so you don't have to unlearn and relearn a new program. So now the roughing is completed in here. If I want to go back and do a finishing pass to a certain area only on the surface in here, I can actually select the surface and apply a toolpath, or I can just do a 3-axis toolpath in here. For the surface, I can use 3-axis and start with a method like a parallel finishing operation. I can pick a tool. In this particular case, I could be selecting like a ball and mill, specify feet and speeds, set the cutting parameters, set the step overs in here, and again I can pick a boundary to contain it, and I can pick this boundary right there. And for the Z-level containment, I can use the same cutting constraints that we put in here. I can pick that, and I can say I only want to go down up to 10 inches in the Z and specify any additional parameters. You can also use skim for clearance control, and then you pick generate. So in this process, it's going to get you a finishing toolpath, and the cutter is only going to cut down to this point. Right? You notice that, sir? Okay. So now I'm going to go into the Simulate tab, and I can run a verification in here. If I hit the play button, it shows the simulation. I can also speed up the simulation to have it go faster or slower. So it's only doing what is called like a parallel finishing pass in here, right? Cutting it back and forth. Now this is just one of the techniques of finishing. Now there are other methods in here as well, which I'm going to switch back and show it to you how you can work with it. So I'm going to pause and stop the simulation. I could go back in here and say for this pocket, I would like to use a 3-axis projection pocketing, and I can pick a boundary. So your boundary could be, you can use a chain of edges. So you can use a chain command in Rhino and automatically pick this. It'll pick the entire chain around the part for you. So once you notice that it picks the entire chain, you can select that, and now you can use the same or similar type of tool for it and specify your cutting conditions and generate. So that's going to generate what is called a 3-axis pocketing operation. So you can do a parallel finishing and exclude this pocket from being machined on a parallel finishing operation, and you can do a combination of different operation types. So that's the beauty of being able to, use an advantage of all the advanced 3-axis methods. Can also be done as index machining. If you want to do like a 3+2 or machine from different orientations, you can still use all of these advanced 3-axis methods in an index 5-axis setup as well. So while this is being computed, you can add additional toolpaths in here. So for example, I can go back to this parallel finishing operation, edit this operation in here, go back and add additional boundaries, and say I want to add a chain and pick this area around the part right there, and it'll automatically give me a chain selection as you see it. And now when I go back and generate the parallel finishing, you will notice that it's only going to be generating the toolpath between the two areas and not cutting into all of the areas in there. So you'll see that the parallel finishing is now excluding these areas. and then the 3D projection pocketing is only cutting into this area right here.
Cool.
So you have a wide range of 3-axis toolpath methods that you can use. Now let's look at machining this one here, right? This particular surface has a draft in here, right? That's the one you were concerned about, right? And the longer, yep, a long reach tool will not be able to cut to it. So you want to basically use like a side of the cutter to cut it, and then you want the tool to tilt, right? At an angle. Am I correct, sir?
Yep.
Okay. So one of the things I'm going to do here is, since this part we need to split this in here into half, so I'm going to select the surface that we have right here. It looks like you already have a split surface. That's great. Okay, that's on the inside. Okay, so the exterior one, I'm going to basically do what is called a trim or a split. So I'm going to do a split in Rhino, and I'm going to use an ISO curve, and I can pick an ISO curve near the quad point over here, and also pick an ISO curve over a quad point over here. So that basically is going to split this into two halves. So I'm going to do a split, ISO curve, and I need to split it, toggle the direction. I'll split over here, and I'll split the surface over here. So you don't have to explode, you don't have to make any editing, deletion. So you can see that the model is now split. Do you see that, sir?
Yeah.
And I can also check the direction of the normals, which way it's pointing. So it's pointing away from you, which is good. So now I want to go ahead and do a toolpath. In this case, I'm going to do a 5-axis toolpath. And there are several different ways we could do it. We could start with a method like between two curve machining, and I can select two drive curves. I can pick a curve on this edge over here. One of the ways I can do it is I can automatically create a sketch in Rhino. I can pick the surface, and let's say, for example, I wanted to move it on to a new layer. I could say, change object layer, and all you're looking at is this particular surface. Now when I do a duplicate edge, you can actually extract the curve from this edge of the part right there, and do the same thing over here. So now for the toolpath, I could go ahead and choose to do a 5-axis between two curves. I can select these two curves, the one that you created, and it looks like there's one curve at the bottom edge right there. And now I'm going to also pick the surface to machine as this one right here. So you're selecting the surface, and you also wanted to specify a tool like a 1/2 inch ball mill. In the cutting conditions here, you can specify your step over, you can specify your lead lag angle, your tilt angle in here, so you have the controls for it in here. So if I put in a lead lag angle of 45 degrees, I can specify a step over and then pick generate. It's going to produce a between two curve machining toolpath. So you can see that the toolpath is being computed, and we can, there's a lot more control in the settings and the parameters. I'm just generating with the lead lag angle of 45 degrees. So you basically want the tool to be tilted at an angle of 45 degrees, right? So the tool is now tilted, and let's go ahead and run a verification here. So I'm going to just run a verification with just the part on it, and you can see that now you have it tilted at a 45 degrees. So there's a lead angle. So that's the lead lag angle, but we want to do what is called not a lead lag angle. What we want to use is actually a tilt angle in here. So here you can set this to 0. You can change the tilt angle to 45, and again you have all of these controls in here to establish the additional parameters. You can specify the distance change, and you can generate the toolpath. So there's a tremendous amount of control that you get. So you can basically tilt the tool to a certain angle to cut it, so depending on how you want it to be processed. So now you can see that the tool is set at a 45 degrees. So do you see the difference between the lead lag angle versus the tilt angle, sir?
Perfect.
Are you seeing it in the tilt?
Yep, works good.
And here we are using a fairly small tool, but like a half an inch, but you can see that it'll maintain that as you cut all the way across. And then we did split it to that angle right there, as you noticed it. So this is how you would use the controls for tilt angle, lead lag angles to program true 5-axis toolpath. So this is using a continuous 5-axis motion.
How does it look in the other way of doing it?
You mean the indexed way of doing it?
Yes, sorry.
Okay, so in the indexed, you would basically tilt. So what you would do is you would go ahead and do what is called a setup in here, and you want to rotate it to like a 45-degree angle, and in this case I'm going to do about X, right?
Okay.
And I would have to define a boundary to program this area in here. So I could go to do a 3-axis operation. I would have to do like a 3-axis horizontal finishing toolpath, and I can define a boundary for it in here. So for the boundary, I'm going to go ahead and create a line. I'll put in a line right in here. I'm just going to throw in a large boundary in here. I'll probably just snap to the grid. So basically what we need to do is rotate the C-plane by 45 degrees, and you want to look at it down from that view. So I'm going to use C-plane. I'm going to rotate the C-plane on the X by 45, and then I'm going to set the view to plan. So that's what you can see when it's rotated at that angle, right? Do you see that, sir?
Yep.
Okay, so what we can do here is in this particular step we can select this and define a boundary for this. So I can select this surface that you have in here, and I can do what is called a duplicate face border, and I can do a method called like a between two curve machining for that angled face in here. I'm going to do what is called a duplicate edge, and I can use a 3-axis like a method called between two curve machining, and I'm going to pick this curve that we have in here and the curve that we have at the bottom edge of the part, select those two curves, and with the same tool selected, and I'm going to specify the parameters. The step over distance I'll just put in as a 1/4 of an inch, and then generate the path. So now let me go into the perspective view here. So you'll notice that it was not able to get to all of the areas in here because you're locking the tool axis to a given orientation. So the tool stays locked in there, but then you're noticing that the head is not constantly rotating. It just stays locked, and you're doing a 3-axis toolpath. So as you get towards the sides, you will notice that it may not be able to reach all the way out to the side.
What you have to do is break that up into smaller pieces, you know?
Right, you have to break it up into smaller pieces. So in the case of index machining, you're locking the tool axis to be normal to that plane that you created out of this XY rotated plane, and you're just programming a 3-axis operation. So you may have to break it up into maybe 2 or more sections, right? So that's called index machining, and we will still output the angles for it. So when we post-process this operation out to the machine, you will notice that you have the angle that's being output right there. It says C90, B315, or it could be the other angle, B could be -45. So we can specify the rotary axis limits in here. We could go back and define the machine tool for the rotary axis limits. We could set it to -110 to +110. That's typically the case on most machines. And now if we go back in here and repost it, you will notice that the B would be at -45. C is rotated to 90 degrees, B to 45. And it stays at that orientation to do the entire process. So you can break it up into multiple sections. Now, if you did the continuous machining, like we did here when I posted, you will notice that it constantly, varies your B and then the C right there.
Yeah.
So that is the simultaneous 5-axis output. So the simultaneous is offered or included in our premium configuration. You can do both index and simultaneous. Our Pro configuration offers you index, where you create additional setups in here to program the toolpath. So for example, I could have a setup that basically splits up these into just this particular section in here. So I can select the curve that I have here, right here, and let's say I want to move it to a new layer. I'll make a copy of it. I'll say copy object to layer. I'm going to hide these, and I'm going to go into the top view, and maybe I'll just throw in a couple of lines in here to split it. I can split it a couple of points in here. So I'm going to do a split it at a point, and then I'll just go split anywhere along the curve. I'll just go split at 2 points. I'll pick a point right there, and I can pick a point right over here. So the same thing I'm going to do right here is split it a point right over there, and maybe right over here. So these are split into 2 sections, right? So you can be creating multiple sections for splitting, and I'll split it right in here as well. So now when you go back to your indexed operation in here, I can edit this operation, and I can select these 2 curves and generate the toolpath. So you're basically only programming to a smaller section at that orientation of 45 degrees. And then you can basically have it rotated to program this section in here. So that's how you can index it to different orientations. Am I making sense here, sir?
Yep, I understand.
Okay. So from what you've seen so far, what would you think would work better for your application?
Well, I mean, obviously, ultimately, the simultaneous program was going to be the best thing, but just whether I can generate that kind of money just yet for it. I mean, we can learn to do it on the other way and start off and get our feet wet, and then as we go.
Yeah, so that is one of the options that you can look into, where you can start with the index process, so you can get the machine up and running, get your feet wet, get started, and then you can step it up to the Pro. That's the nice thing about our product, is there's the options available to upgrade configurations from one to the other.
No, I think it's got you got all the right ticks on the boxes right now. So.
Okay, well, that's good to know. And if you want to work on this surface in here, we could actually do like a swarf cutting operation on it, so where the side of the cutter is used rather than the tool being normal to it. That's also something you could use in the 5-axis simultaneous module, where you try to maintain the tool being parallel to this, or you can orient the plane at an angle, and then you can program a tool path as well if you just don't want to do like a 3-axis operation. So you have a variety of different ways how we can program it. In the 3-axis, you have a whole bunch of 3D methods. So you have roughing, re-roughing, machining of flats, different types of finishing techniques. All of these can also be used with index 5-axis. So as you noticed here, we just programmed one of these at an angle. Now I can go ahead and program this area in here as one operation. So I can add a new rotate table setup, or sorry, new coordinate system setup, and I can rotate this by a certain angle in here. So I could say I want to rotate, I can put it back to, rotate it back to 0, right? And then I can rotate it about 45 degrees on the Z-axis. And then I can do a 45 degrees on the X now, right? So you can create any different angle or orientation in here. And you can do a combination of different ones. You can even put a plane in here and have it be normal to the plane. So you can use Rhino's tools in here. You can establish a plane using 3 points, and I can just go pick any 3 points in here to say I want to use these three as my reference points, and there's the plane, and I can go back to the setup and I can say I want to use active construction plane. So the coordinate system is oriented to the plane.
Yep.
And if you want to go back and change the angle, I could say I want to rotate it by minus 15 degrees on the Y. I can tilt it back up on the Y-axis or X-axis. You can do that. And now you pick a boundary in here to machine this face. I can specify a boundary in here. I could do a duplicate edge in Rhino. I can basically just get this edge right there from the model. Right? I can split the edge and then just machine that section out there on the toolpath. So that's how easy it is to define your boundaries and program it. So now I've duplicated this edge. I'm going to do a transform. I'll do a copy. I'll say pick from point. I'll do just a pick from point right here. And I'll copy this point right here. So now I have two curves. I'm going to just repeat the same operation for the index between two curves. Copy and paste it. And I can just select the curve we have right in here. And I can pick the curve right in here to program the toolpath. Now you notice that this is not on the model, right? So I can get the curve back on the model right there, but I'm going to generate this toolpath. So you'll now notice that the toolpath is going to be, it says only two curves can be selected, so I apparently seem to have only one curve selected in here. So I need to go back and select the two curves. And now I can generate the toolpath, and now you can see the toolpath is generated for that section. And now when I run a verification in here, you'll see that it's tilted at an angle, and the posting will take care of the angle output for you. So this is how we can accomplish indexed machining.
Yeah.
Now if I post these two setups in here, I'm going to select the setups number 2 and 3, post it. You will see that the first one is C90B45. I'm going to do a find for the next value for the rotation. And you'll see that the second rotation is C151B minus 54.3. So the system automatically figured that out. Any questions, Jeff?
Oh, so there's a lot to learn. There'll be definitely some late nights digging through it, trying to make it work.
Well, we have a lot of video tutorials. We have training materials. We have resources that are included with the product. You can also access. Customers have access to our CAMJam video recordings and also webinar recordings for, we do one each month, a webinar each month for customers who are active on our maintenance program, and they will have access to all of those archives as well to go back and review it. Plus you do get priority support for helping you troubleshoot issues where we can even log into your computer to help you out on it.